We're going to look here at a tricky integration by parts question. Now this probably is a wee bit beyond what you might get in A-level mathematics, but A-level further mathematics this could come up. So this is one where we're going to have to integrate twice, but we're going to see a very important integral in this, which is integrating ln. Okay, so we're going to say here in this question by the way came from the excellent Dr. Frost Maths, fantastic website for all different resources. It says, use integration by parts to find the integral of 9x squared upon ln of x squared. Now, if this didn't have ln x wasn't squared, we could do integration by parts once and do it, but the ln of x squared makes it a little bit more difficult. Okay, first of all, what is integration by parts? Here we have our integration by parts formula. So if you integrate an expression which is u dv by dx, and you integrate this, what you get is uv, so this thing has been integrated, minus the integral of v du by dx. Now typically what you do is you pick your u such that your du by dx is a much simpler function. Now, and I'll put a link in the description to how we integrate ln of x, but if you've got one where there's a ln of x, you don't do that, you actually make your u equal to your ln of x, and in this case your u is ln of x squared. Your dv then has to be the other bit, which in this case is 9x squared. Now we'll do it. If we integrate dv by dx, it takes you back to v. So if you just integrate 9x squared with respect to x, raise the power by 1, you'll get 9x cubed, and divide by the new power, that's just going to give you 3x cubed. Now this bit, this is the chain rule. So we're going to use the chain rule to do this, to get our du by dx, differentiate with respect to the power. You're going to have 2 times ln of x, just, the bracket just goes down to the power of 1. Differentiate ln, you get 1 over x. So what we have really, it's 2 over x times ln of x. We'll tidy it up. Okay, now we'll write down our formula again, because it's easy to forget. The integral of u dv by dx integrated with respect to x is uv minus the integral of v du by dx. So in this case, the integral of, 9x squared times ln of x, it was squared dx, is going to be my u times my v. So there's my v, and times, there's my v, and there is my u up here. So if I just multiply those, I'll put the v first this time, so it's going to be 3x cubed times ln of x, and the ln of x is squared, then minus the integral of my v, I've got my arrow at my v already, and then times my du, so there times this. So 3x cubed times 2 over x is just going to give you 6 x squared. I need to put an x6 at the top there, so it's just going to be 6x squared, and that is going to be times ln of x. Okay, right, now we have to investigate this. So this bit is already integrated, don't have to do anything with it. We're going to have to investigate this thing over here. So we're going to call this whole thing equation 1, and now we're going to investigate how we integrate ln of 6x squared ln of x dx. So this is where this is going a wee bit beyond what you would normally have. So we're going to have to do this and then put that back into equation 1. So here your u again is ln of x, your dv by dx is going to be 6x squared. We'll do the easy bit first. If we integrate this, raise the power by 1 goes up to x cubed, and divide by 3, 6 divided by 3 is just 2x squared. And here, if you differentiate your ln, you're going to get 1 over x. Now, that means, let me just write that down again, integral of 6x squared ln of x dx is my uv. So there's my u times my v, so that's going to be 2x cubed times ln of x, then minus the integral of my v times du, so 2x cubed times 1 over x, that's just going to be 2x squared. So it's 2x squared dx. We can now integrate that bit. So it's going to be 2x cubed ln of x, then minus, and if you integrate that, raise the power by 1, you will get a you'll get 3, so x to the power of 3, and then all divided by the new power, and then plus your constant of integration. Okay, we're going to fire that back into equation 1. So there was my equation 1 up here. So this bit here, which I've highlighted now in yellow, we now know what it is worth from down below. So we'll put that all back in. Okay, right. So it was the integral of 9x squared ln of x. So the integral of 9x squared ln of x squared, I should say. And it was equal to, so it was 3x cubed upon ln x squared. And then minus of this thing here. So if we minus this thing here, so we take this away, I'll just show that. So it's going to be minus of 2x cubed ln of x minus 2x cubed over 3, and then plus the c. And then if we do that, you're going to get that's going to be 3x cubed brackets ln of x squared, and then minus, and that's going to be 2x cubed ln of x minus, that's going to be plus 2x cubed over 3, and then plus c, remember your constant of integration. And that is it done. So a wee bit more complicated maybe for regular A-level mathematics, but A-level further mathematics, something like that could come up where you've a repeated integration by parts to do. Okay, for more free resources on A-level further maths, you can see my website there, www.nimathstutor.co.uk, and there's free A-level further maths resources for AS1 and AS2.